Hello everybody, welcome to the aoe2 AI scripting tutorial number 6. This video we will be looking at using comments and regions in Notepad++, relative operators for level 1 to 3 programming, prefix types for level 4 and 5 programming, relative operators for level 4 and 5 programming, building houses, a new strategic number, initial exploration required, and researching loom. Using comments in Notepad++, using the semicolon or point comma. This is put in the beginning of a line to comment out code you want inactivating. For instance, you don't want this def rule, you can semicolon the whole def rule. You will see it turns green. We did this in the past with a def rule we wanted commenting out for the time being. You can also use a method in Notepad++ by right clicking and block uncomment to uncomment it, right clicking block comment to comment the whole def rule or a line. You can also use a semicolon after code for other cases, for instance for adding information or clarification, like after strategic numbers, cap civilian explorers nil, I don't want to explore with villages, for instance. You can also use it to divide parts of the programming. For instance, semicolon defining constants, defining civs, chatting data, and so on. With Notepad++ and the aoe2 scripting language installed, it shows green. Using regions in Notepad++. You can use semicolon region and semicolon end region to mark a region in Notepad++ in your code. If aoe2 scripting language is installed, you can see video tutorial number 4 for this. For instance, you can define a region, setting up scouting. After the scouting, you defined end region. Don't forget the semicolons. What this does is it sets up a region, symbolized here with a square and a hook, and you can close this hook like this. If you do this for different parts of your code, it will become very much overviewable. I will demonstrate. We've got defining constants, defining civs, chatting some data, like this, setting up scouting and programming. Doesn't this look neat? If we want to change something or view something, we can open the square, the bracket, by clicking the plus, and we get the relevant code we want to look at. This is to create scripting blocks, as we have seen. to have a better overview of the code. Like comments, regions themselves are set up in green. Using regions doesn't have any influence on the execution of the code, as the AI interprets the regions as comments as they start with a semicolon. Now some theory. Level 1 to 3 relative operators. Syntax is often showed as rel-op. How is it syntax? You've got some command stuff, rel-op, and a constant. And we've already used this in a few cases, like unit type count livestock class greater than 0. Two versions can be used, either symbolic or written. The written form is called also the full form. Less than, less or equal, greater than, greater or equal, equal, not equal. The symbolic or short form, which is used most often, means the same as a full form, only symbolized. Note, the equation mark is a second symbol if used in conjunction with other relative symbols. In other words, these won't work. You first have to put exclamation mark and then the equation mark, or first put greater than or smaller than and then equal mark. There has to be a space before and after the relative operators, as you can see here, a space before and here. This won't work, greater than or equal to 5, if there's no space between the relative operators and the 5. A mistake that's sometimes made when scripting. It should be with a space in between. Now we jump to level 4-5 prefix types, also called type operations or type ops. You often have to define what type of parameter you use when using level 4 and 5 programming. You've got different parameters, for instance constants, goals and strategic numbers, where you have to use a prefix C:, G:, or S:. The parameter prefix C:, is sometimes optional, but as a good rule of thumb, always include the C:, in level 4 and 5 programming to avoid errors when a type op is asked. Don't use a prefix in level 1 to 3 programming. It is for level 4 and 5 programming. We've already encountered these prefixes when we had the following def rule, defining a constant starting fields on sheep, for instance 6, and it chatted the data to myself. I need 6 villagers on sheep, the %d referring to this constant here, but you had to tell the program, because this is level 4 programming, upchat data to player, you have to state with the prefix C:, that the following is a constant. To give another example, you can use this on strategic numbers. For instance, you want to see what your exploration situation is once you have 10 civilians. So def rule civilian population equals 10. What do you have to check then? You have to chat the data to yourself. I have a number of explorers. The number is gotten from the strategic number, total number of explorers, if you remember from the scouting video. But because SN total number of explorers isn't a constant, but it is a strategic number, you have to tell the AI this by putting the correct prefix S:, SN total number of explorers. We know when to use a prefix when we look at the command syntax. For instance, for upchat data to player, don't worry about the other elements in the syntax, but it does have type up before the value. When you see type up, they mean put a prefix. This is important for level 4 and 5 relative operators too, called in the syntax compareOp. Level 4 and 5 programming can use as parameter, besides constants, also goals and strategic numbers to compare to. The compareOp is made up of the typeOp, which is a prefix, plus a short symbolic form of the rel-op without a space between the typeOp and the rel-op. I will just make this bigger so you can see the table. When using level 4 and 5 relative operators, you see with constant it's C colon less than, C colon less or equal to, and so on. Remember, you still need a space before the C and you still need a space after the symbols. Here you get all the relative operators when using a constants. Here you get all the relative operators when using goals, and here you get all the relative operators when using strategic numbers. Don't worry about the level 4 and 5 theory I have just given. In future videos we will work out different examples based on this, but I wanted to go through the theory as we have used certain elements in certain cases. Now we go over to something more fun, which is hands-on programming. Building houses. We have the fact checker can build building. This fact checks whether the computer player can build the given building. In particular, it checks that the building is available to the computer player's civilization, that the tech tree prerequisites for the building are met, that the resources needed for the building are available, and you can use a building line wildcard parameters for the building. The action is build building, and as stated in a previous video, with training, building and researching, always use the can to check if it can. So we close the regions we have set up and we go to programming. Def rule can build house, build house. Like this, we save, never forget to save, and we start a scenario. I have put the map size on giant for a particular reason that we will see in a minute. I also put resources high so we can keep training villages and building houses. This for testing purposes.
Presta.
So it has found livestock. The scout is scouting, but I don't see any building of houses. It does state I have 4 villages, 1 scouting unit, therefore I need to build a house. It is not training any villages as we are pop capped. The scout keeps scouting. We are waiting, and magically, suddenly, a villager starts building a house. Of course, this is quite late, and we have to find out why this is. It is time to introduce yet another strategic number. The strategic number, initial exploration required, and this is why I've chosen the giant map size to demonstrate this. The percentage of the map that must be explored by a computer player before any building is allowed, and the default is set to 2, meaning that 2% of the giant map has to be explored before it will start building buildings. We will set this to nil, as stated here, as explained just. Okay, so def rule true, set strategic number, SN initial exploration required nil. Best also to disable self, that the AI doesn't get confused. Resetting the strategic number over and over again. SN initial exploration required 0%. We save this and we will have a look what the result is. And as you can see, the start is identical. It's found the livestock, the villagers stop exploring, and the one villager immediately starts to build the house. The training has stopped for the time being. Once it's built the first house, it starts building the second house. Once it's built the second house, it starts building the third house. Once it's built the third house, it starts building the fourth house, and so on. Why is this? Obviously, as long as this def rule is true, it keeps reiterating, meaning when one house is built, it will start building a new house. Of course, we can't use the disable self function, because otherwise, after one house that it will have built, it will stop building any additional houses. So how do we solve this? We need a new fact. Housing-headroom with a relative operator, which we saw in the theory, a level 1 to 3 relative operator, and a value. This fact checks computer player's housing-headroom. The housing-headroom is a difference between current housing capacity and trained unit capacity. For example, a computer player has a town center with a capacity of 5 and a house with a capacity of 5. This totals 10 and has 6 villages. In this case, the housing headroom is 4. So what do we program with this fact checker? Housing headroom is smaller than 5. We save, we restart, and the housing headroom here is 1 if we calculate this out of our head. So it will immediately start building a house because no exploration is required as we set this to nil. Now the housing headroom equals 5. It's training another villager. It's training yet another villager. The housing headroom is now 4. 4 is less than 5 what we programmed, and it builds another house. You have taken the shortcut. As I pause the recording of the video, I have taken the long road. Housing headroom 4 again, it starts building a house. Now we see again housing headroom is at 5. I forgot to mention that I put the population limit at 25 also for demonstrative reasons. Housing headroom equals 4, so it builds a house. That's very good, as we have programmed. Of course, this number 25 doesn't go up as our population limit is 25. As we have seen before, a def rule is activated once it is true. If, for instance, a house is destroyed by the enemy, I will just manually delete it for now. The def rule reactivates and it builds a house. This is quite neat, isn't it? Now, our population needs in, for instance, feudal and certainly in castle age mean that the housing headroom smaller than 5 might not be enough to keep up with the population increase, both with villagers and military in those ages. So what we could do is create an extra def rule for where one def rule is valid in Dark Age and the other def rules are valid in the other ages. How do we do this? We put in an extra fact called current age. We use the relative operator and then the age that we want it referring to. This fact checks computer player's current age. Age can be Dark Age, Feudal Age, Castle Age, Imperial Age, and in some cases Post-Imperial Age, which is used with starting age facts, not with the current age facts, but with other facts. But I'm giving Post-Imperial Age as an age for completeness in this case. So what we will do is the following. Current age equals Dark Age. We copy paste this def rule, and for ages greater than or equal to feudal age we want a housing headroom of at least 10 to allow for the rapid population expansion. This is what we've programmed. Now we're going to research loom. We won't make this too complicated. First we look at the tech IDs. See link 5 in the description. I already have it opened. I searched for loom, and here we have the town center techs, ID number 22, loom. The name that we have to use is re-loom. Re is like a phonetic way of saying research. So I put the researching of loom after training of villagers. Why do I do this? Because I want to give the training of villagers priority. As with researching buildings and training villagers, we always have to use the can function. Can research, can train, can build. Re-loom Don't forget the arrow, and then of course research the loom. Don't forget to save, and we will try out what this will give. It is training villagers. The villagers are exploring. They found the sheep, so they stopped exploring just as we programmed, and that one is building a house. The house wasn't finished in time, so it couldn't train another villager. That's why it started researching loom. If the house was finished in time, it would have trained a villager instead of researching loom at that time. Okay, that seems to be working. For future videos, I will already give the ideas I have, not necessarily coming out in this order though. We will discuss drop-off points, meaning lumber and mining camps, also mills, example of level 4 programming using the relative operators to compare, the villager task and distribution strategic numbers using level 3 to task villagers to what we want them to gather. It's a start of creating build orders with the AI. Researching ages, eco and military text. We already saw loom in this video. Boolean operators, which is like and or not, in the facts and facts usage tutorial. Goals, timers, conditional loading, level 2 programming. We will also have another video on more complicated house building, villager training, and loom researching programming. For instance, tasking 2 builders to build the first house, as we as players do it, to have it ready before the first villager is trained to keep the production continuous. Military and basic attack. Of course, suggestions and questions are welcome. Thank you and hope to see you next video. Bye.